Okay, after a little bit of checking, I haven't changed anything yet. Down here, where I'm doing this paint.getGraphics, I've done that for years, but apparently it's a bad idea. It can cause problems. We just call repaint. I've also done that often, and I haven't had problems with that, except that I think this may make things look a little bit funky. Not so bad yet. All right. That repaint can often cause your screen to flash a little bit, and then the paint.getGraphics has been kind of a little hack of mine to make that better before I add in a thing called double buffering. Now you notice that these fireworks tend to flicker a bit. They flicker and flash, and we really don't particularly like that effect. What's happening is you're drawing a bunch of things on the screen, and so as we're painting, as we're executing this paint method, as it's going through this, it's painting things on the screen, and then it immediately comes back and starts over. It clears the screen and starts painting again. And as we get more and more and more and more things to paint on the screen at a time, we'll get to a point where it flickers and flashes, because what you're doing is you're looking at what you've seen is a half-drawn image. Okay? The way to get rid of that is called a technique called double buffering. And so what we've got to do is we've got to draw everything off screen, and then once it's all finished drawing, we flip it up to the screen so that they see it. And so they never see a half-drawn image. So what I'm going to do is I'm going to say private buffered image. I'm going to call this off screen. We're going to have to import that buffered image. And in the constructor we initialize it. Off screen equals a new buffered image. And that new buffered image is going to have a width of our width. And it's going to have a height equal to the height of the J-frame. Okay, so the width is going to be the width of the J-frame, the height is going to be the height of the J-frame. And it's going to have a certain type. So if I type in buffered image dot, I get the list of all these different types. And the type we want is int RGB. So an image is made up of a bunch of pixels, and those pixels are stored in some sort of format. The format we're using is int RGB, stands for, or BRG, blue, green, red. Now inside of Paint, what we're going to do is we're going to get the graphics object of the buffered image, of the off-screen image. So I'm going to say graphics I'm going to call this G2 equals off-screen dot get graphics. So we're getting the graphics object of that image, and then wherever we're drawing to G, instead of drawing directly to the screen, we're going to draw to G2, that off-screen image. And then at the very end, we're going to add one more line, which takes that off-screen image and draws it onto the screen. So we're going to use G, which is for the screen, and we're going to say draw image. And there's a list here of a bunch of draw image things. This is the one with the fewest parameters. That's the one we want. It wants to know, what image are we drawing? We want to draw the off-screen image. And where do we want to put it? We want to put it at 0, 0. And we need an image observer. Well, it just happens that a J-frame is an image observer, so we can just put that to pass that to the off-screen, or I mean to the draw image method. It says there are some errors. We got to get rid of them. What is this? The static field fireworks with should be accessed in a static way. That's new to me. What if I just say width and height? Okay, that works. Yeah, right, because instead of saying this is an instance of the object that I've got. And because they're static, I don't have an instance. I need a semicolon here. All right, better. Flickering and flashing is gone. Yay! So that's progress. Now I'd like to make those explosions round, yeah? How do I do that? So when I create those velocities, I'm picking x and y coordinates that are between negative 2.5 and positive 2.5. Well, if you think of those as locations, it's locations within a square. And those locations within a square are going to give me a square explosion. So I need to pick locations within a circle. I'm going to add another little interesting little thing. I'm going to say do and then I'm going to say while. Now once I pick these, I'm going to calculate the distance. I'm going to say double distance is equal to math.sqrt of Vx times Vx plus Vy times Vy. And then I'm going to keep repeating this and as long as distance is greater than 2.5. So if I think of a circle that's just barely inside of that square, it's got a radius of 2.5. I spelled distance wrong. I need a semicolon. It's complaining about the scope of distance. If I declare a variable within the squiggly brackets, that variable lives and dies between the squiggly brackets. Now I've got another issue because I'm using Vx and Vy down here. This Vx and Vy live and die between these squiggly brackets. But I've got another Vx and Vy inside of particle that are protected. This Vx and Vy are accessible within particles. So if I have access to these and access to these, they're both two variables with the same name and they're both within scope. I have access to both of them at this line of code. If I have access to both of them, it will use the one which is most local. This one would mask out that one, except now by adding these squiggly brackets with the do while, I have limited the scope of this Vx and Vy, and now my particles are not going to do anything except they're going to have the exact same Vx and Y of my projectile. It would run, but I get kind of funny behavior, right? Not what I was expecting or hoping for. So what I'm going to do is I'm just going to take this and I'm going to declare those variables here. And then I'm going to, instead of declaring variables, I'm just going to use the ones that are declared. What that essentially does is it expands the scope of these two variables from these squiggly brackets to the slightly larger squiggly brackets out here. So now I have two VXs available. The most local ones are these, which got assigned inside of the do while. The way a do while works is it's a lot like a while loop. It says do the stuff inside of the squiggly brackets. It's going to go in and do it. And then while it evaluates to this as true. And if it evaluates to true, it keeps going through. And it keeps going as long as it's true. So it does it. And then as long as this is true, it keeps on doing it. As soon as this is false, okay, so it keeps doing it as long as I pick points that are more than 2.5 units from the center, essentially, of the circle. So it's going to exit as soon as I pick two velocities that are a distance, when I calculate their distance from 0, that distance is less than 2.5. When the distance is less than or equal to 2.5, I get out of the while loop. So now, yay, round explosions. So cool. Haha, that's awesome. Now I'd like to make it look a little bit better. All of my particles just kind of disappear at the same time, yeah? I would like them to, and you know, that's not the way fireworks are. I'd like them to kind of fade out individually. Well, that's not too hard. When I create my particles, I set the size to 5. What if I just said something like, oh, math.random times, oh, I don't know, maybe 3 plus 3. So the smallest particles are going to start out at size 3, and the biggest ones are going to start out size 6, but they're all just kind of going to be a little bit random. And so some of them will shrink down to less than 1 quickly, and because they start out small. And some of them will take longer. So now when I run it, they don't all disappear at once. And we can play with those parameters a lot to get a little bit different effects. Then the last thing that I would like to do to really make this look cool, I'm going to reduce the number of particles a little bit. I'm just going to make 100 particles. Now those don't look real fancy, right? Let's make it a little bit fancier. When we clear our screen right now, we set the color black and we fill the entire off-screen image with black. And that essentially erases everything that's already on the screen, okay? What if we set it to something that is black but a little transparent? So instead of completely erasing it, we just fade it out a little. I'm going to say new color 0.0f. If I add this f after a number, that makes sure that it's a float. If I just type a number 0.0, Java's going to think it's a double, and when I create a new color, I need floats, not doubles. So I can type 0.0f to make sure that it's a float. So I don't want any red, green, or blue, so I give it zeros for that. But then I add a fourth value, and I'm going to say 0.25. This last number, 0.25f, that last number, if I give a fourth number, is going to control my transparency. So this color is a little transparent. Actually, it's very transparent. It's 75% transparent, and it's only 25% visible. So the things behind it will show up a little bit, but they'll be faded out. And if I just do this repeatedly, you'll see what happens. It's pretty cool. I like it. We've got trails. Notice how, as I move this, you can sort of see a line behind it, and then my sparks have trails. I want the trails to be bigger. So let's give it a lot more transparency. Let's say 125. The smaller number you make that, the more transparent it is, and the longer the trails are going to be. Okay, so that's pretty cool. Except that, those things all fly in a pretty straight line, and we know that's not how projectiles fly, right? Let's add a little gravity. Gravity's easy. So when we update, if we change the velocity a little bit, gravity just kind of is always pulling down, yeah? So if we just change our Vy, we say, oh, Vy plus equals some small number, I don't know, 0.1. That's always pulling down, because remember, positive y is down. If we are always increasing our velocity, that's like pushing on it. That's applying a force, and forces change the velocity. And so gravity is a constant velocity, always pulling down. And now, oh, we get nice, beautiful arcs. Isn't that cool? That might be a little much gravity. You can play with the parameters. There are all kinds of cool things we could do. We can make circular explosions. We can make, so this is round, they're filled in the middle. I want you to play with this. Add some features. Have some fun. If you have any questions or problems, make sure you send me a message in Canvas. Thanks.